We're recording. Welcome, everybody. Today is Saturday, the 9th of October. This is DPRG's regular meeting. And today we're going to try something a little different than normal. We're simply going to go around the room and talk about thoughts that we have on what kind of robots we want to build next, maybe what kind of sensors. And, just letting the sky be the limit. What if time and money were not constraints? Maybe we have some personal targets, or maybe we don't. Maybe there's a really clear, focused path, or maybe there's nothing but a whole bunch of ideas, or maybe just want to pay attention and see what's going on.
Carl, are we recording?
We are recording, and if anyone would not like to be recorded, just speak up and we can pause it. But I assume we would just record for those that aren't aware. So you can speak up and we can pause it, or if you'd rather not say anything or be recorded, then don't say anything. So I thought, just for grins, I sent this out. I noticed it at lunch, but just for kicks, here's some kind of crazy idea, right? A walking robot that flies. So okay, let's mix up the platforms there. So the sky is the limit.
Carl, I looked at that and read the article. It's more than just flies. Those rotors have to be turning for it to walk. That is, that's how it balances. And if you look, the legs are very simple.
Oh,
and
yeah.
It also appears to have on high heel shoes.
Yes. I noticed that. Obviously, a woman robot.
So why would it have legs at all in that case, I'm thinking?
Well, one might ask that question, John.
There you go.
Yeah.
Oh.
I mean, other than touch, I could see it for, feeling the surface maybe, but...
It kind of moves like a marionette, doesn't it? But
Did it have it on the tightrope? It can walk a tightrope.
Yeah.
But
One thought would be, if I wonder if, it looked like it was very lightweight made, though, and they're maybe trying to conserve power, and maybe by walking they can lower the power requirement because they don't have to lift the weight.
Right. Might also help with positioning, but then again, with video cameras, I noticed like my little Mavic drone does a very good job of holding position.
Mm-hmm.
That's sort of an interesting thing. If you could sort of use drone technology, but yet kind of restrict your motion, sort of interesting.
Well, they're not having to balance with the legs. That's the trick. Legs just push this flying thing along the ground, but the balance all comes from the propellers. So, with a walking robot, the hard part is balance and, responding to being pushed and stuff like that. Well, here the four propellers are handling all that, not the legs.
And I would think you could I'll have to play with my drone to see what would happen if I dangle some legs from it. Although I think it tends to have a land sequence, and it also gets upset about things. At least without using a stock DJI drone, I guess might be difficult.
There's a mode you can fly in that turns off the, the landing sensors and so forth. Well, Carl, I didn't put my hand up, but you're showing that I have something that could segue right into it if I can jump in line.
Well, I'm seeing Doug. Pete,
go ahead.
Yes, go.
Why don't you lead us into this then, David?
Okay. Well, this is actually two-step.
Sure.
What I've wanted to do for a long time, let's see, with this balancing robot, one thing it cannot do is get up by itself. And and I've thought for years about different ways of doing that. And what I've actually settled on, if you guys can remember, I know you haven't seen this guy run in a long time. These are bumpers, those made from rubber hose. And here's another one that protects it because it does fall over. And so the idea was, let me back up. Suppose that I had a bail, basically replace this handle here with something that went like that. And better yet, right here, and it would serve as a handle. And right here in the middle of it, it would have a little wheel. And then that needs to be run by something like some sort of high torque drive, maybe a worm gear or something like that, and can pivot either way. And you only have to get the robot up to about 30 degrees before it can jerk up on its own. So also then, because I could do that, I might be able to do other things with it. Like, for example, I could lean it back and just rock back onto that tail wheel in a position of rest. Or if I thought I was going to fall over, which you can sense because once you hit full speed, you can't, you see how to describe this. It's sort of like if you're running downhill when you're a kid and you start building up speed, and after a while you find you can't slow down. Because what you have to do to slow down is you got to move the center of gravity behind your legs. And the only way to do that is to move your legs forward. And once you're running full speed, you can't move your legs forward anymore. And so as a child, what you do is you start slamming your feet real hard into the ground, trying to burn off some of that momentum so that you can run fast enough to get your center of gravity behind your base so that you can slow down. So that's the same problem here. You can tell when he's going to fall over because he's leaning and running at full speed. And at that point, maybe you could deploy this thing to at least catch yourself when you're falling. Also, you might actually be able to use that in some way as part of the balance algorithm.
Yeah.
So, okay. So all of this had started long, long ago when I was thinking about walking robots. And that the real problem with when I built this robot, I spent all my time trying to get it to balance. And I thought, okay, how do you get it to drive? Well, it turns out that if you make it balance, you've done everything you need to do. All you have to do is tilt it and it will drive. And you can tilt it like a Segway by standing on it and shifting your body weight, or you can actually just shift where the up vectors are in software, and it has the same effect. So I think it would be the same with a walking robot. That is, the gait, everybody concentrates on the gait. I bet the gait might arrive automatically if it was self-balancing. And to prove that, I want you guys to do a search on robot passive walking. Do a Google search on robot passive walking. I'll do the same thing.
Follow the articles.
Okay, there should be some videos there, right?
And videos, yeah.
All right, let's go to the video. There's one called Passive Walking Robot Propelled by Its Own Weight.
Yeah.
From Ikinamo on 2011. Watch that video.
Can't you just put it on the screen and?
Yeah, I got it coming. Here we go. Once we get past, oh, look at that.
Now, there's actually a guy about 20 years ago whose name escapes me at the time that built the first one of these. And his initial one could only walk downhill, but it walked on its own. There's no actuators, there's no motors, there's no batteries. And the reason that this is intriguing to me is because this is probably how we do it. One of the things that people who study bipedal walking robots observe is that all of the functions that we do now use an enormous amount of energy to walk compared to what humans do to walk, which is basically you just kind of fall forward, which is what this is doing.
So there's friction, which means that it's taking energy for the motion, but I guess that's being provided by the conveyor belt in this case?
There's some papers that that's describe this pretty accurately, and the guy who built it built another one some years later, and the only sensor it had was there's a button when the ball of the foot went down, and the only actuator was basically to push off when that foot is in the rear. And with those two functions, it could. Anyway, as I said, the people who study this suggest that this is actually the way we walk, and it's why we are able to do it such low energy. You know, we're think about it. You eat one jelly donut, you can walk 10 miles. You know.
It's sad, isn't it?
All right, that's the end of my story. That's all I had to present.
That's pretty cool. So an upgrade, and at some point you might delve into walking robots.
Well, the problem, I can't actually do the upgrade because basically that robot is stuffed full. There's no room for anything. I can't add any more weight to it. And it would have to be another robot. That's why I've actually never done it. But I actually think it would be cool to have a robot whose main mode of locomotion was two-wheel, but could also drop down into a three-wheel or even a four-wheel. Think about going off-road like a human does. As the slope you go up gets steeper and steeper. After a while, you go from two-legged to four-legged mode. You know, you lean forward and start using your arms. And so it seems like the robot could do the same thing in a really steep hill.
Cool. All right. All right. So for those that haven't just joined, we have David got us started, and then we're going to have Doug, and then John, and then I, and then whoever wants to go after that. So Doug P., what's on your wish list and brainstorming?
Okay. Well, let me do the presentation here. Entire screen. Share. Okay. Okay. So first thing I tried to do was go through and decide some goals for the next year. And one of the biggest problems I have is getting defocused by so many cool and neat things that are coming in that I can't stay focused. So I basically tried to have one indoor and one outdoor goal for this year. So my outdoor goal is to score at least 6 points in the Robo Columbus, and that's probably going to happen in October of 2022. All right, so plenty of time for that, and I'll be talking about my robot. The second one is to complete a personal indoor robot challenge that I've given myself, and I'll explain that later. And then, as we drop down, I'd like to have some form of an AI CV function on one of my robots. I just want to make that transition to having some sort of AI CV type part of the robot. Then I'd like to be successful in May's Robo Rama competition. But I can probably, that's not a strong goal, but it's a goal that I'd like to do. And then as we keep going down, I'd like to implement a 2D LiDAR on some indoor robot. This is something I've gotten the parts, I've played around with it, but I've never really got it. And then there's a stretch goal, and I'll talk about that. And that would probably be in the November indoor competition right before Christmas. All right. So first of all, I have two robots that I'm going to talk about. One is Pilot Buggy. If you were at the competition this was it August?
August.
Yeah, you saw this robot. It's based off of a Quantum Vandom XL, which you can't even buy anymore. 1/10 scale, four-wheel basher type RC car. So it's not the rock crawler type. It's a basher. And is that the ideal combination? Probably not, but it doesn't seem to have any problem going through thick St. Augustine grass and 3 or 4 inch curves and that sort of stuff. It can handle it. Some modifications are it has a 60T brush motor with a 15T pinion, and it has something that was key, and I didn't have it until actually after that competition, is it has a ESC that has a forward reverse mode. The one that I had at the competition only had forward brake and forward brake reverse, which I can never get it to really reverse. So the best I could have hoped, if everything had fallen jelly side up, would have been to go to the first cone and stop and hit the cone. That's all I could have done because I couldn't back up. So, you know, and this was a path that I took when I first put this together, is I went ahead with an Autopilot, which happens to be the Mega-based Autopilot 2.6, and it has a GPS unit. And this year, I actively created a local processor, which would happen to be an Arduino Mega, because that's the way I was trying to do it in the time. And I used a Pololu 4-channel RC servo multiplexer to allow me to go either Autopilot or local, because you really only have 2 signals coming out, or 3 signals. You have 3 signals. One of them is steering, one of them is speed or throttle, and the other one is your safety switch. So those are the only 3 channels. So where the robot gets its input for those 3 channels on my robot now can either be Autopilot. So like if I'm far away from the cone, I can let it roll on Autopilot. But there's some problems there, but I'll talk about that later. And then or I can switch to local, and I have everything under my control. Okay, let's see. And something I did, I have an encoder on it, which gives me about 270 edges per wheel revolution. So I can perform odometry on this robot. I didn't use it this year, but it's something I'll plan to use later. And to find the cones, I was using a Pixie 2.1 with my own special sauce, which is an auxiliary Arduino Mini, which handles all of the conversion and just passes on a turn left, turn right signal. It had 3 ultrasonic rangers. I did not find them to be very useful, but that's because my robot never moved off the pad at the competition. But I believe that they were useful, and I actually successfully touched the cone. All right, and that's pretty much it. This is what it looks like. So I'm going to go over here. One thing I did this year was I put on a set of NeoPixels, and this is my decoder ring. So I can tell when my safety, because when you're running behind the robot or walking behind the robot, reading a display is very hard to do, but seeing bright pixels, bright LEDs is pretty easy to do. The biggest problem with them is knowing which one is which, but with a little, thought, you can figure out how that is. So here's the 60 turn motor. Here's the ESC. Here's the Mega with a sensor shield on it, which breaks out. So everything has a signal, ground, and VCC input for each lead. This is the NeoPixels. This is the Pixie, the bottom of it. You can't really see the camera. And the UBEC is over here for providing 5 volts. And there's the sensors, robots. So, it's pretty typical. Here's what the Autopilot looks like right here. So the accomplishments this year, well, I touched and stopped after move. I actually touched the cone and stopped. Not a competition, but at home. I'm able to now switch between pilot and control. I can receive, and this is a key one. This is how I communicate between the Autopilot and the local is what they call MAVLink messages. And I had some, but I didn't have everything I needed. And I now know how to do that. So that's cool. And I got the encoder calibrated and actually used it in speed PID on the local. So that's cool. But now I'm probably going to also use it as an odometry. So here's the needs. I need to get some additional Mavlink messages so that I can eliminate the use of Mission Planner, which is what I think screwed me up at the competition. I'm going to utilize the odometry information better. I'm going to go ahead with a little better improved search cone algorithm. Right now, if I approached the cone and did not see the cone, even though I've got a very wide field of view, if it didn't happen, since I couldn't turn backwards, I was pretty well squirreled on how I could do it because of the turn radius thing. This thing is humongous. But I got some other things I'm going to do. So here's and you can see the others, the ideas now. So one of the things, so here's some ideas that might be cool. I don't want to increase the rate of the rover, and I don't want to have a display on the rover when it's running. But I'm going to add a port where I can use my little 216 display in auxiliary Uno so that I can test the sensors and the wiring pre-run. All right. Now, is this absolutely necessary? No, but it would really keep you when, you have a transport related issue, and you always have those. So, and plus it's already designed. I simply have to put it in a box with a separate power supply. I probably don't even have to use a separate power supply, just put it in a box. Okay, I want to add brightness feedback loop to the Pixie. And I've talked about that in our robot builders night virtual, and I'll show it later. And here was something I'd like to try. I would like to use the encoder and the current information to determine if the robot is stuck. Otherwise, essentially, if it's sitting there spinning its wheels, that's going to have a different current profile than if it's actually got traction. So what it would do is switch to local and initiate some unstuck maneuver, which might be hopefully successful. And then I would like to add an SD card storage so I could run the data on review afterwards. You say, well, why don't you use a teleport radio? Well, it turns out that they're over long range, they seem to be kind of iffy, or at least the ones I've got. And then eventually, when the OD light comes in, I'd like to supplement the Pixie for acquiring cones. And then finally, this is the one that's got me really stoked. Then I want to add rear steering to the chassis. So here's the idea of adding the brightness sensor inside of the polarized filter container to do it. And I've talked about this in Robot Builders Night Virtual, so this is essentially a inverse of the current configuration, so that this robot would shoot this, Ranger would shoot this way, and this Ranger would shoot this way. And I think that would be actually, I'm going to try it. We'll see how it works. And then this is what they mean by rear steer. It's common on some rock crawlers, but not on bashers. And what it means is that if this is the rear of the robot, and you can see the wheels are tilted and the front wheels are tilted, this greatly reduces the turning radius. It also allows some weird maneuvers that you might not think about, like you can, but the main one I would be using is just to reduce the turn radius. So here's on my robot, here's what the rear wheels look, here's what the steering wheel looks. So if you look, so this is the front of the robot, and if you look where the holes are, these are the servo mounts, and these are the steering arm post. There's a post that goes into these guys right here. That's this one here and this one here. This is the servo saver, and this is the link to the servo. So I think I've got a spare base coming to my home, and I think I can modify it so that I can basically make the back end of the robot look like the front of the robot. with, now there's differences because you have, right in this area, I have my encoder, and right here is the main motor sprocket. So anyway, I'm gonna play with it. Okay, so that's pretty much that one. And now on my indoor robot, I just call it Doug's test robot because this is something that I'm a philosophy that I've gone to that I think has been really successful. I've got basically a standard custom laser cut chassis and 3D printed parts. So I don't have to do that every time. I just take them and put them together. I've found a set of motors that works with this chassis that has encoders, and they're cheap. They're only $7.50 a piece. I'm using about the cheapest motor controller you can use. I am using an IMU, a BNO 055. I'm going to experiment with some other IMU units, but this is what I'm using. Mega with a sensor shield. These 407 ones, the more I use them, the more I'm impressed with them. They're IR distance sensors. This is the current configuration is 130 with a rate of 100. But by changing, I think, one jumper, I can modify it to a max range of 3 meters and with less resolution. But it also drops the update rate. But I think that's because of the timing of the pulse. It'd have to be 3 times. So anyway, and that's pretty much it. This is what it looks like. And I think the thing I want to point out, so these are the IR sensors I'm talking about. And this, if you notice here, there's 2 screws. So this whole unit right here can be removed. In other units like the Oak D light can be easily mounted into this position. All right, and it has clear forward view. This is the 2x16. This is all a package unit now. That code, you know, I don't have to change it at all, except when I'm asking for new sensors. And in this particular one, I did try something a little different to add output support to the wheels. And that's still an experiment. Okay, so here's where I can do with it right now. With my software base, I can go from waypoint to waypoint using odometry. I got simple obstacle avoidance, and I improved the code base. So what I'm trying to do here next is add mapping and path planning. That's what I want to do. Here you can see these are my two sources that I'm working with right now. The first one's really simple, and the second one's a little more complex. I want to improve my obstacle avoidance routines and add bumpers. That's simple. And then when I get this mature, I want to move it to the Club 2016 robot. All right, I'm going to use this as my test base for the Oak D light. If I go to the 2D LiDAR, I probably end up with a new, you obviously looking at that superstructure is not going to work. And I'm also doing some PID loop time tests where one of the problems is when you slow the velocity of the robot down to say like 3 inches per second. That's pretty slow. What you're going to run into is that you're only going to be looking for like 6 or 7 edges per PID period. So that means that if you're let's say you were targeted at 7, well, the next one you'll have is 6 or you'll have 8. That's a fairly big jump. So what I'd like to do is in those cases, maybe change the PID loop time to say double it. So now you have 14. anyway, that's an experiment that's in progress.
Doug, I know you know this. Another way you can approach that
Yes.
is by measuring the time interval between ticks.
Yeah, I have tried that because I once was forced to use a really crappy encoder, and that's definitely I probably need to revisit that, David, because I haven't. I am aware of it, and that's usually how they do it when they don't have, like they don't have very good encoders. So
Also, if you've got a quadrature encoder, a lot of drivers will allow you to trigger on all 4 edges, so you get 4 times as many.
all right, well, I'm doing that
You're
already.
already doing that. Okay.
Yeah, but 20 milliseconds, and I mean, this is not a problem at probably normal robot speeds, but I'm trying to test stretch the abilities to see how slow I can go. Otherwise, I'd like to even be able to move it, like I said, 3 inches per second. That's not even a wheel revolution. Okay.
I know Larry Borello out at the Seattle Robotics Group, he did his pig controllers based on time between ticks rather than ticks per unit time.
Yeah.
And Doug, he could make it move 3 inches per day. It was actually kind of astounding.
Okay, I got to get that. So I definitely got to look at that. I'm capturing that, Dave, because that's really, like I said, I was aware of the technique. I actually tried to use it once, but it's not been tried on this robot.
Doug,
Yes.
so one comment and I have a question for you. So indoor robot, I'm actually trying to do something very similar. And instead of your Arduino Mega Stack, one thing that I discovered recently, which I'm trying to use or replace my Arduino Mega
Mm-hmm.
with, is the ESP32 version 2. It's a very tiny footprint one that you could buy for $20. And it has the built-in, the I2C LED screen built into it. So it's very small, and
Okay.
is the version 2, if you do buy it, make sure you get the newer version. Version 2 has the 8 megabyte flash RAM on it. And I actually received mine just the other day. So I'm going to try to use that instead of my Arduino Mega, which would help with the footprint.
Could you put a link to that in the chat? That would be
Sure.
really cool.
Sure. I'll send you the one that I got. Actually, there's 2. So ESP32, and there's a Lola version, has the enhanced communication module. And
Mhm.
this actually lets you even flash your RAM over the air. So I wanted
Okay.
to play with that as well. I'll give you the link for both of them.
Okay,
But
great.
the question I had was, if you replace your sonar sensor with like OCD light,
Mm-hmm.
I don't see you have a computer like Raspberry Pi or anything in there. Would you have enough computing power to process the data that you got coming in from the OCD?
There may need to be additional power. Okay. Everybody else is most people are using some form of, Raspberry Pi to do that. Okay. Now, it does have Movidius in it. And so it does accelerate its own AI work. So there's a lot of things that I don't know about the OD light yet, but I feel my robot platform is versatile enough that I could add a Raspberry Pi if I had to. Okay. Now I'll be quite honest. At that point, I'm more worried about the OD light's power requirements. It takes 1.2 amps. Okay. And that might be a bigger concern with the batteries that I'm using on my current indoor robot currently.
Is that at 3.3 volts?
No, that's at 5.
Gosh, I've got motors that don't draw that much.
Yep. Yeah. And I don't know if that, I don't know, David, if that's like, okay, if you're really doing something super crazy as opposed to just coasting along. So there's a lot of things like that. I don't know. They just warn you that right now they have an add-on that they're selling to their Kickstarter, which basically what it does, it's a very nice little module that all it has is takes one USB-C and splits it out to 2 USB-Cs so that you can bring in 2 power sources. All right. So, and they're selling it for $19 and probably because of the form factor, probably worth getting at least one of them. Anyway,
what was your reason for using the Dasher as opposed to the rock crawler?
at the time, I did not know enough about rock crawlers. If I did not have the investment that I have right now, I would consider rock crawlers. One of the problems with rock crawlers is compared to the Basher is the weight that it'll support. The Basher, you saw all the superstructure that's on it, and it just trucks along through the grass. There's no issue at all. So my concern would be that I would have to seriously have a weight management budget to do with a rock crawler. But a rock crawler has a lot of advantages. Like, you wouldn't have to replace the motor, or wouldn't have to replace the ESC, wouldn't have had to, I could probably, the rear steering would probably not come with it, but it would be something that you could add on fairly reasonably, because there's a lot of things on the internet about that.
Also, Doug, don't forget that there are lots and lots of different strength springs and shocks available.
Yeah, that's true.
So you can.
That's true.
I had to do that on the.
Also, some of the rock crawlers are already front and rear steering.
Yeah, and some of them have a brake mode where they can literally do what they call. Essentially, what they do is they lock one of the back wheels, and then they just pivot around. You know what I'm saying? You can see. Otherwise, they tilt like they're going to use rear steering, but they lock one of the wheels, and they just pivot around on that locked wheel.
Like a tractor.
I guess. I'm not really, don't know much about rock crawlers. And because of the challenges and what I've overcome so far, at least for one more year, I'm not going to write off the Basher.
Well, Doug, I have 2 questions.
Yeah.
Under capabilities, you have simple obstacle avoidance.
Yeah.
Have you actually ever videoed or demonstrated that to us? Have you ever got a gold star on your forehead?
I don't know.
I don't believe I've ever seen it.
Okay. Yeah, but it's really nothing much. It's pretty much, I see an obstacle and I turn back and I change a random angle and try to go forward.
Still worth a gold star.
Yeah. Well, I differ in you on this, on how just because of the way my software evolved. I try to make everything look like a waypoint. Otherwise, when it goes through my loop, one of the things it does is it looks at its target location that it's trying to go through. That's either what I'd call a normal waypoint, or it's one that's called a temporary waypoint. That way, through the loop, it doesn't care. It just goes through the loop. So that's different than the more organic way that you have. And I'm not really pleased with the current obstacle avoidance. I want to return it back to this, everybody's a waypoint. It's just a matter of where the waypoint's pointing. And so what I probably will have is some sort of, okay, I've got an obstacle. Well, if I'm mapping, I probably just turn 90 degrees or 45 degrees and forget about it. But if I'm just driving and something steps in front of me and I'm just trying to go to a waypoint, I might again use the right, left, or center, depending on which way to turn, hopefully. But then I'll probably just turn until it drops off of the forward-looking forward-looking sensor, and then set a distance before in front of me, and I waypoint. That's my temporary waypoint, and I just drive to it.
Well, my second question has to do with the Oak D light. I've been involved in some lengthy conversations with Kareem,
Yeah,
and kind of trying to understand how he's approaching all this, which is basically from an image processing point of view.
yes.
But as I've sort of learned from him what he's doing, it's occurred to me that there's a much simpler way to use that device that might not actually require a Raspberry Pi. Excuse me. Spam Risk is trying to call me.
Oh, no, I know.
Uh, which is that he has basically, you can think of it as a frame that has the, oh, go away.
Pesky spam fly. Leave me alone.
He has a frame, so you can think that's basically a depth map,
Yeah.
and where each pixel represents a depth.
Mm-hmm.
And so he's spending a lot of time trying to figure out how to remove the floor from the image so that he can separate out what is an obstacle and groups of obstacles and so forth. It seems like that there's a simpler way to do that. It might work especially well on your robot, which is this is actually a variation on the more standard problem we've all run into, which is how to keep forward-looking sensors from seeing the floor. I mean, that's basically what the problem is.
Mm-hmm.
And the way we do it with sonar arrays and things like that is you put the array down low and you angle it upward.
Mm-hmm.
So imagine you did the same thing with the camera. You put the camera down low and you angle it upward such that the bottom trace, the bottom scan line just clears the floor. So now everything you can see is an obstacle that is separated from the floor.
Yep.
And you can use that basically like a big fancy array of sonar measurements. Use it the same way. A simple way to use it would just say, okay, let's just divide the screen down the middle. And I'll define some closer than this I don't want to go. And if I find any pixel on the right-hand side, I turn left. If I find any on the left hand, I turn right.
Yeah.
Or if they're on both, that's a center detect. So there's not really any image processing required, and that's where it seems to me all the boogers come from.
Oh, I agree. How I would do that, and the way I showed this at last Robot Builders Night Out, is that you can essentially define, and there's no reason why you only do one, but the example program has a region of interest. Okay, so it's a little box on your camera field, and it averages the depth of every pixel that's in that box. There's no reason why you couldn't have, say, 6 of those across the field of view and pick up different. So if you suddenly saw one that was like, okay, here you're 4 meters away and all of a sudden you're 37 inches, you know that you've got an obstacle in front of you. You might not know what it is, but you know it's 37 inches in front of you.
And it doesn't make any difference what it is. This is not object recognition.
Right. Yeah.
So what I suggested to Kareem, of which he expressed zero interest, I described, okay, on JBot, there's 4 sonar. And you can basically think they're 15-degree fields of view, so about 60 degrees for the whole thing. And so you can think of them as 2 center ones and 2 side-looking ones. And for the sonar avoidance behavior, the 2 center ones trigger at about 8 feet, and the 2 side-looking ones trigger at about 2 feet. That allows you to go through narrow openings. So now you take your depth camera, split the thing into 4 ranges. As a matter of fact, you probably want the center 2 ranges to be smaller than the outer 2 ranges, but at any rate, and then you define a trigger for each one of those. So if basically you got 4 columns, and you say, I actually don't care about objects. What I care is there a detection that's closer to me than whatever. In my case, 8 feet for the center or 2 feet for the side.
Yeah.
And if there is, I respond to that. I don't care how many of them there are. If there is as much as one, I respond to it. So as I said, basically you're able to use that as a really slick, sophisticated, wide field of view sonar array that also tells you vertically where in the image it is. So for example, if it's 8 feet out in front of you, but it's 4 feet up in the air, your little robot can probably ignore it. You can probably drive right under it. So you have a whole lot more information, and it's more regularly spread out than with the sonar. But that would be a way to use it without having to do any image processing.
Yeah, I think that when the OD gets into everybody's hands, I think there'll be, because I think there's several people in the club that have ordered them. I think that it'll be really, really interesting to see what we come up with. I would love to see us get together and address those type of issues. You know, maybe put our brains together. Anyway, now I'm now.
The
I'm
main
shifting.
I'm sorry.
Go ahead.
The main suggestion was just that this step of trying to separate out the floor from the obstacles could be removed by mounting the camera low and tilting it up slightly, the same way we remove it for IR detectors or sonar detectors, so that they don't hit the floor. And then this fairly complicated step of how to remove the floor from the objects just basically goes away.
I'm not sure.
Automatically.
Yeah, I'm not exactly sure why Kareem is doing what he's doing. I can only assume that there's some part of the problem that I don't understand.
Well, what he described to me is that he's looking, he wants to do something that's more like mapping, where he can know where the front and the back of an obstacle is by looking from a high angle, and plan routes around it.
Okay. But can you do?
He didn't think he could do that if he was mounted low looking up.
Well, we're going to find out, because with the sensors that are currently on my test robot, this is the challenge that I want to do. All right. Now, I've demonstrated at Robot Builders Night Out that, I can make the robot turn, drive to here, and drive to here. Actually, it made an extra turn because there's a big table here. But essentially, by driving by waypoints. But what I want to do is to be able to say, this is the waypoint, and I got to get to it. And you can see I've got the potential trap that you mentioned, David, a long time ago, that if I get in here, I'm really, really looking at, the waypoint's almost exactly across from me. Well, so what I really want to do is have this robot. This is why I want to try mapping, to see if I can map to this. Now, is that the best solution? Maybe not, but that's the one I want to try because I don't know enough about it. And why do I do this? I do this to learn. So anyway, so this is my personal goal. This is in my entryway. This is in my kitchen area. And I'm going to get from there to there with just one waypoint. And so that's one of the things. That's the goal for the indoor test robot. Now, but it was built along an idea, and that is have a simple assembly of parts that can be turned into a basic robot quickly. And it allows to rapid build a basic robot for test ideas. Now, what drove me to this was I was trying to teach a course of beginners, okay? And I wanted the robot we were using had a lot of problems with it. But what I wanted to do is create a chassis that was extremely flexible so that they could put their different processors on it. They could do all sorts of weird stuff. And it would be essentially, you took 3 or 4 parts, and the hardest thing would be wiring up the power supply. Okay. And here you can see, if you look at this one's probably the closest to that basic robot. All right. It's got a Uno on it with a sensor shield. It's got a 298. Normally it would have had where this a Huffy lens. It would have had sonar on a pan and tilt, and it would have had 2 IR sensors touched at 45 degrees here and here, which gives it a really good obstacle avoidance. I mean, the thing won't hit anything. It does a real good job on that. But so I wanted, and this is something, here's the basic parts, you know, it's got a standard chassis that's laser part and 3D parts. And you see, here's the 3D parts, one here, 2 here to hold the motor in, 2 here to hold the other motor in. That's it. All right. So there's 6 3D printed parts and two of these DF Robot TT motors that have the encoders on them. They're $750 a piece. This guy's about $3 or $4. These are, depending on your stash, probably you might not ever have to get them, but if you do. And these robots, there's 2 types. There's one that David Ackley turned me on to, which is also from DF Robot, which is a better wheel than these guys. These aren't too hot, but I had a slew of these, so I used these while I was doing this. And then just some wire and DuPonts. So this little basic robot I can get a new sensor. I can just flip something together. I don't have to tear anything apart. I don't have to make anything that's working stop working. I just build a new one. And it's very inexpensive. So this was an idea that I thought might be something that other people might be interested in. And, you know, you don't have to, you can use, you know, here's one with a Raspberry Pi in it. Here's one of Uno. Here's a Mega over here. I don't know what this one is. Oh, that's a Uno. And you can do some weird stuff. I mean, you can really go nuts if you want to. So I have done this, and you know, I could make this available if anybody was interested, and probably make some documentation on it. But it would be a robot that you can essentially put together for $30, maybe $40 if you really don't have anything. If you got any of these parts, you don't have to. You know, I'm really, you know, one I probably make next will probably do with a Pico. I got a Pico shield just the other day. All right, here's my other active robots. I'm still working with these, but I'm not going to talk about them. And here's my stretch goal. I have this. It has a sensor monitoring point, and I'd like to use it in some competition, probably November of next year, not this, you know, not May. And here's the build links. So this is really interesting. So the one I have is essentially this purple one. They did they did one with standard servos, and it came out to this big. And now they have one that's called the Gigapod, and you can see this one is actually 32 times bigger than mine. So I don't know. I'm not going there, but I want to make this one work. We'll see how that goes. Okay, new stuff. Okay, LP LiDAR S2 is coming out, and I think it's kind of expensive for me and probably wouldn't be high on my list. One thing about it, though, that does look really tempting, it's got 80. It supposedly has an 80K light tolerance. Texas sun usually runs. I mean, full on sun is usually 100K lux. So could be decent. Okay, it does have a weird starting up, I guess, because the motors inside of it have to start up, but I don't know how big a problem that would be. Probably not. And then the OD, this is the next one. So if you haven't got one, they're up to 89 now. And that's it. And now, then finally, things that I don't like, and I'm not sure exactly how to get around them. One is the multiple IDEs. I'm running it. This is the one I'm using on most of my C code. PyCharm is being used on most of my Python, and NetBeam is using on the Raspberry Pi when I'm using the C, because you essentially develop on Windows, and then when you compile, it actually compiles on the Raspberry Pi. So that's kind of cool. Some of these other ones might do that, but this one I already have set up. And then for the ARM stuff, I'm still using this one. I don't know or it may be renamed this. I can never keep up with ST. They're always changing their names. And I've started to play around a little bit with a Pico, but remember, this is a distraction. It has a lot of promise. And I haven't really tackled the ESP32s. Yeah, they're not new, but I've been avoiding as a distraction. They are very powerful, especially if you get one that has sufficient I/O on it. But I have a project that I really want to do that this guy is like saying, use me, use me. So in some, I'm overstimulated. There's so much to learn. I'm just freaked out. So that's pretty much where I am. Those are the state of my robots.
How do you solve the multiple IDEs dilemma? Because I'm sure we all face that.
Well, like I say, if I can do it in Platform IO, I'll do it in Platform IO because I finally figured out how to use it. Same thing with PyCharm. If I'm in Python, PyCharm is beautiful, but you know it's, and I think there's a version for Raspberry Pi, but I'm not sure. You might have to use this one on Raspberry Pi.
Who made that? Was that the
that's
Pi Foundation?
Who?
PyCharm.
No, PyCharm is no. We actually had them sponsor us once and give us. They used to have a model where you could buy their product, their commercial product, and PyCharm was wrapped into a bigger. You know, if you wanted to use Android, if you wanted to use their Seeker, everything, and they gave us a certain number of licenses, and we actually auctioned them out as prizes. But now their model is a subscription model, so it's less because before, you know, you had like 1 year of updates, and then after that you would work forever, but you wouldn't get any more updates. But a lot of these things don't really change that much. But now they have subscription, and I won't do subscriptions. I got, you know, they really have to do so. But it's not PyCharm. I don't remember their name, but it's a company, a commercial company. In PyCharm, they have a community version that you can use, which is free. And I don't know, not knowing the difference because I'm not a Python expert. PyCharm community is plenty enough.
Mm-hmm.
Well, Doug, that's pretty cool. Thanks. So I think at least I can resonate with the overstimulated theme, but you got a lot on your plate, dude.
Yeah. Well, like I say,
the second half of 2022. Okay.
So outdoor, Robo Columbus.
There you go.
Indoor, personal challenge.
2 targets.
Which means mapping. So those are the 2 that I'm going to, even over obstacle avoidance.
No distraction.
Mapping. And those are the 2 things I'm trying to accomplish.
All right.
All these other things, they're going to distract me. I can tell you.
Excellent. We'll do our best to distract you.
Yeah.
Too many shiny things to look at. Yeah, it's like, ooh, look at that.
Ooh, my shiny.
All right. I think next we have John K. Then this guy Carl's going to go, and then who would like to go after me? Then, if we just think about who's next. Okay, think about it some more. So then, John K., if you want to jump in.
Okay, I will jump in. Regard to indoor, I'm toying with this being the indoor. I don't have, it has those, the $15 whatever encoder reel on the front end. I really don't know how many encoders I need because effectively I have 2 encoder reels and the others are not So right now, I think that's probably sufficient. I wish the encoder was in the center in some ways instead of in the front. So I may
Well, John,
move them.
John,
Yes.
it depends on your goals. If you want true motor control on all your wheels, you're going to have encoders on all your wheels, and you're going to
Right.
have to be running six PID loops.
But I'm thinking just two. And so that's why I'm thinking maybe move it to the center wheel versus the outer wheel.
Well,
That's probably makes sense.
But I don't know if there's enough room for it to fit in there between the two. As you see, there's a little room there where here it's all nice and big because it's on the top there is where the encoder is.
is that ABS? Is that ABS the material?
This is a plastic that was yeah
ABS, yeah.
form ABS,
Yeah.
but it was pre-cut, laser cut basically.
Yeah.
So this is my indoor robot. Right now I have nothing other than the motors on it. As you can see, it's it has a nice top to put stuff on. So that's the thing. Now I'll probably build a little clog in the front, and that's why it has room down underneath to put the pincher. So I'm thinking a pincher could go there, so it could even be the Syscan contest one. At least I'm toying with that for the Syscan. So this is sort of the next 6 months project.
What processor are you looking at?
I'm torn between, I like my Adreno boards, I love them, but I like Raspberry because of more memory and vision type and Python. So I may wind up going that route. It's a debate. I actually have both processors, so I lean toward the Raspberry, but it would take more time. The Adreno board I already know and well, so. But I'll probably do the base and then jump over to Raspberry. It's my thought, and allow for the flexibility. So that's sort of the current thing. Now, future-wise, after that, the thing I would love to do is, let me click on a window. Okay. Yes, share that. So I've always been, interested in the movement of legs. So I've built the Strambys, but what I have not done is built one where it has just 4 legs for balancing. So I may toy with building the cat or dog or whatever you want to call it version. So, and there's several out there now, but I'm toying with building basically a 4-letter version. And there's this article, for example, that's pretty good. So I may go with building something like this as for future plans. So so I've always been interested in that. So I may go with this. And as I said, this article looks pretty good. So, and then that way I could get the vision in there too, because you notice they have the camera on this one. Hence, that's why the Raspberry eventually move into Raspberry.
Is that one of the ESP cameras on there?
This one, what did they use? Okay, do they have? Yeah, they use a PS RAM camera.
Yeah, which is okay.
So that's something along that lines. It's a matter of which one to go with. I mean, this happens to be a pretty good one. He even goes into the voltage in the article. He goes into the voltage and how much voltage it needs, and hence why separate batteries and stuff like that. So this article looks pretty good and pretty thoroughly done. So he talks about the brain. And as I said, definitely into the voltage and that. So, I would recommend looking at this article. It looks pretty good. Then after that, if I get through that, then the next thing would be on movement. Let's see. I guess I can just click and close it down. That'll be the fastest way to get there. And then percent now, a window, and then that one. And after that, as I said, I've always been interested in movement other than wheels. So the other thing would be is maybe like a snake type robot. Or a well, in this case, they say a self-configuring robot. So to me, you know, movement of that type looks interesting. This one, you know, they say it can go. So this one, they actually can make it like real, which I thought was sort of interesting movement.
It's pretty cool.
Yeah, that's why I said some, yeah, snakes slash movements that are not normal reels, basically. So that's sort of would be my long-term plan. But my goal is not to get distracted too much and sort of concentrate on April or May. Hence, that's why probably this, you know, couple months work on that one chassis I have.
John, I'm a little confused. That last video,
Yes.
is that like an animation or was that actually
No, that
a
was
power
a real.
device?
It was a power reel.
What is the power source and what are the actuators?
Shoot, I may have closed that window already. Yeah, well, I can pull it back up. Servos in it. It was 3D printed.
Control Shift T will reopen the tab, John.
What? Well, I had closed the window down, so I had to do a little more clicking than that. But yeah, but see, what they did was, yeah, you know, so it could go through a tube, for example. And
No, I see that little device can. Is there some picture on the inside showing what the power and what the motivation?
well, the power, well, they had
To
a
the
lot
right of
there.
that one in the tube.
Let's see. Okay.
See what
3D
they-
printed parts, 22. You use a needle, and then you use Bluetooth module. Probably. Okay.
Well,
and
maybe
Okay, there it is. It's a 600 milliamp single cell lithium ion battery. Now the question is where they put it. This must be bigger. This must be bigger than it looks.
Well, that's one picture. Let's see if we can figure out how big it is. Okay, there's.
Well, it's got it's
another one.
they're showing it's 92.
Okay.
Okay.
See, so there's, you know, one servo.
Yeah, that's pretty. It's really pretty big.
I guess that's what threw me off.
Probably around 6 inches, I would say, give or
Maybe
take.
almost a foot when you think for the whole thing laid
Well,
out.
for the whole thing, yeah. So there's your servos, and there's, you know, one segment.
I put the URL to that thing in the chat, so
Okay. Yeah, and then there's.
These slinky
Okay. And there you, as I say, to me, a snake movement would be interesting. So hence.
They're supposed to put their camera, 35 millimeter camera lens cap in the picture so we'll know how big things are.
That would be nice. But I mean, based on, you know, the fact they're using those servos. Yeah.
Well, those are the small servos, but they're still pretty big.
at the top of the page you can see a photo.
Oh, there you
of
go.
the
There
thing.
you go. There you go.
There's an example.
There you go. Yeah, you can see there you got the male DuPont clips.
Wonder where that ribbon cable goes.
Well, it goes in probably to the next linkage. Because, yeah, you know, notice where you put one
Oh, there you
item,
go.
and then he has like a stretch down there below. So, yeah.
There you can tell. I mean, those pins are what, 100 thousandths on that, whatever it is, nano or whatever the board is.
No, it's a nano. He went for small. So,
Yeah.
I mean, you can see how much he has trim in that little spot.
So Ron, you're saying use the pin spacing as our
Yeah, as your ruler, maybe
With pin spacing. Yeah.
100 thousandths on that nano. Well, how many pins does it have on a side? 20? Not quite. 15.
About 20, I think they do. Okay. But yeah, I've always been interested in the snake movement. So after I do, the four, when I went from, multiple legs, the strand beast to, to a two version, which, I have somewhere up here. I'm thinking the 4-letter and then to the snake sort of design will be the
So
far future one.
So you think each one of those segments has a battery?
No, it could, but I don't think
It's only
so.
got one. It's only got one, so it's
Right.
powered from somewhat one of them. Not sure which one, but it said a 6 milliamp hour battery.
Yeah, it could be. Well, I will almost. Well,
Yeah, there you go. So that whole segment had a transceiver in one segment, and what? How many
Right.
servos? 1, 2, 3, 4.
yeah. 'Cause there's like,
Where do you see a fourth one?
well, you see, there's one of these,
Yeah.
and then there's one of those, and then the center one probably is that one. Yeah, that's probably the center one right there. And then they have two end pieces where it looks like on this one they have some type of solar sensor on the front on the here.
It's as long as a kitten.
Yeah, and there's another matron sick. The cat, yeah. So as I said, to me this looks interesting for his movement. So if I may bump that up a little in the front line. So, yes, problem with destruction, as you said.
We're all overstimulated, eh?
So this is an interesting movement. What you could do with it and thinking as a snake, and it will allow you to go over object easier and stuff. So it has sort of the best of both worlds.
It's
Could you
not
imagine
clear.
trying to add sensors to every segment?
It's not clear it can turn.
In this case, I don't think he has designed to. Other than I don't think it is really geared for turn. I've seen one somewhere out there where they actually had a little bit more movement, but
It looks like the one that you're pointing at is actually two segments tied together. You have the red one at the end, a gray red
which is
one,
a half,
and then half.
Right.
Yeah, and you end up with a gray half. Okay, colors don't match, but
Well, only the reason why I think the color matches is down below. Is that this is a solid 2 gray, and then this has
red,
half
gray,
color, half color, half color.
Yeah.
And the key is you can make this however long you want it to because you just keep adding segments on it. And and unfortunately, I think this is the only one video that he has of the bunch. I'd be curious to see the video for in the tube, but
Maybe that's a static display. I don't know.
Yeah.
Maybe it didn't do too well getting through the tube.
But you can see how it literally can do that.
Yeah.
So at that stage, it literally could roll, and the only thing is it doesn't have a turn. So.
Oh yeah.
But I'm thinking it could, effectively, I think what you could do though is, right. I don't want to get back up.
Maybe design it so you have one turning axis in the front.
Right. So that when, okay. So there we go. So effectively when it was all 4 together, then you're right. Have that so that the top could turn down to the side. So it would just have to have one the spot where it has more of a rotation axis. Now, I think you could probably even make this turn without too much problem if you build a sack like that. And it looks like ideally 4 is the nice number based on this. Yeah, right there. You see, you can actually have the, turn the axe on there and there, so it just lay on its side basically, and then reconfigure it.
You say basically double the number of servos.
Well, yeah, you could. As I said, it's an interesting design though, and a snake slash movement is sort of the next thought I've been toying with doing. So we'll see on this.
It's kind of interesting. I mean, if you think about it, the way you might have tried to approach something like that is where you make one segment do everything. So it is an interesting idea, a compromise perhaps a little bit, but maybe it makes it simpler and more doable is to have multiple segments that then share like a battery in one or whatever. But I guess it is the idea of a uniform segment that's the same that you replicate. That sounds really enticing, even though more difficult to do.
So can you see like in this tube, this part here, if it could turn, and then like when the axis there, that would turn. So this spot right there, you would almost need to have it be able to turn. So so as I said, long term, it's an interesting subject that I will toy with, but I haven't figured out exactly how, and I haven't really seen a good solution out there anywhere yet to how to build a snake effectively.
I wonder if it's like those simple worms that you cut in half, and each one grows as a new worm.
A self-replicating robot.
Yeah. Just keep cutting it in half.
Pretty cool.
So that's sort of my thoughts of where to go this next year on what sort of projects, and relatively inexpensive projects, I hope.
Nice. Well, I think we're looking forward to see that alternate locomotive then, John. That'll be fun.
That'll be more toward the end of the year. As I said, there's one out there where they use like fish and thread I've seen.
Yep.
And I'm thinking that might be one way you can get around that problem of how do you get the up angle and the side angle at the same time for the segments. So so
cool.
Hopefully I plan to play with that somewhere.
John, I think you have the ability to look at the largest number of shining lights or shiny things. So,
oh no, Ray, pot calling the kettle black. How can you say that?
I do tend to have very diverse, diverse hobbies / things. So you're right.
I think if there's one common thread amongst everyone on this call, that's it. So
we all follow after shiny things.
Oh, look over there, squirrel. All righty. So I think I'm next in queue, but then we didn't have anyone yet in queue after me. So if somebody got some.
Well, I've got just a couple things to show, and not really hardly show, but just things that have inspired my interest. But I can wait. I need about 2 minutes.
You get your 2 minutes. I'll give you a couple more than 2 minutes, but I'll jump in. So.
Okay, Ron, it's 2:27. Go ahead.
Okay.
No, Carl's going, right?
I'm going to go first.
Yeah.
So I please don't take what I'm going to show as overly stimulated, although maybe that's the case. It's basically I'm in the mode now where I've spent the last 5 years in the club getting basic skills together because I hadn't messed with this stuff, mechatronics or even really software. And so I spent a lot of time on functionality and getting things to work and getting a kind of set of tools and things together, patterns of. But now the only decisions I've made for the next year involve buying things because it's easier to buy. It's easier to buy the stuff than actually do anything with what you buy. So I'll start with that and then head in the direction of where I haven't decided yet what to do next. So the first thing I've got on order is the Oak D light. And it sounds like there's going to be so many people with this in the club that maybe what we ought to do is put our minds together and figure out, maybe there's some kind of contest or target. We could all see what everybody comes up with this and use that as a way to see what kind of different approaches can we get from this thing. But until it comes in, all right. Then recently I got one of these, the Open MV Cam H7. And then I promptly lost the rest of the summer with my trip to Pittsburgh and shoulder surgery and all that junk. But Raj really bailed it out when he got that to work on the robot that we had in Robo Columbus. But I still want to actually play with it, aside from just duct tape it to the platform that I made. And I actually want to play with the optical flow on this. So that's one more little sensor thing I want to play with. And then there's this one, the optical flow, that I guess Kareem and Murray helped Pimoroni make, convince them to make. I don't have one of these yet, but because I've been enjoying the kind of the cannon wheel robots, and the encoders just are only good for wheel velocity on those. I've been thinking of what could I do if I had optical flow of one kind or another on a mechanical wheel base. So those are the last kind of technical sensory things that are on my near-term list. After that, what I really, really want to do somehow in the next year is look more at the robot's aesthetics. And as some of you may know, I have this kind of long-term inspiration of the steampunk kind of aesthetic. And so, I actually want to redo the office that I'm sitting in to look more like one of these. Like, wouldn't that be cool to have a steampunk little robot office build place? And my wife definitely wants me to do something about the current messy junkyard aesthetic that I'm working in right now. So we'll see. So that's kind of on my list, that aesthetic, but it also carries over to robot-y things. So like I just like the look, that kind of crazy look, right? It's and someone made one of these apparently. Someone made one of these, right? So it's not at all practical, I'm sure, but hubless wheels, right? So you got Art Deco, you got steampunk aesthetic, you got hubless wheels, and I just really like the look of those kinds of things. Or that guy, the whole vintage, and I just think it would be really cool, functionality aside, if you could have something that's marginally functional, but have some aesthetic that blends those kinds of things, or even that, right? So and there actually is, this one's not by a real steam engine, but I've seen, I think, some motorcycles that are steam powered like this. So
that one looks like it's compressed air powered.
Yeah, but
actually powered by an air engine.
But I just like the look, right, of the iron and the copper and the gauges and the springs. I just think it's a kind of a cool look. So somewhere in there, I have a whole bunch of other inspiration pictures, but I couldn't find them quickly. Somewhere in there, I wound up actually buying one of these. So this is a Nixie tube, but it's actually a bar graph indicator Nixie tube.
Wow.
And this particular kit on Tindy, it comes with it comes with a tube and a driver card. So you got to solder the parts on and such, but then you can actually drive this thing from an Arduino, and you can set the length of the display on the Nixie tube. So I'm thinking that'd be pretty cool to incorporate into a robot, right? Maybe it's the depth sensor if you've got an ultrasonic or a range sensor, or maybe you have a couple of these on the side, and they, like when the motors spin faster, that it makes a sound or something.
Carl, are you familiar with that prop? That's the red lights that move back and forth. That's been a science fiction movie in the last 30 years.
Yeah, I sent that link out. I think the most important.
You can make one of those.
Yes, yeah, that's I didn't think
Most
to bring it up.
important device in the universe.
Most important, and it's really funny to look at that if we dig it out from the DPRG list, because I mean, how many movies has it been in, and you
Yeah,
don't think anything of it.
20 years of science fiction, and as they point out in the article, no one has ever in any of those movies said what it is or what it does.
No, it's just there. And most of those movies, it's on the same base, right? Maybe they have an extra little thing on it, but it's the same kind of white base, and it has these.
One of the movies, they hooked up a box to the end of it with a bunch of PVC pipes going into it and some wires.
Yeah.
This is the LED equivalent. It's 101 LEDs. It was made by HP.
Yeah.
And you'll multiplex them in groups of 10. So it's like 10 of them, in, I think this was common cathode.
Yeah.
So the question of the day is, what was the predecessor to that prop? Think about it. What was the thing you'd see in all science fiction movies?
Okay, what's that famous talk that the guys at General Motors gave in the 50s?
The turbo encabulator.
Turbo encabulator was clearly the predecessor.
Oh, okay. I was kind of thinking the Jacob's ladder was the thing.
Me too,
Oh,
yeah.
Oh, you're right.
And the oscilloscope with the sine wave.
Oh, yeah, there you go.
Jacob's ladder is more Frankenstein.
Yeah.
I would love to have a Jacob's ladder or a spark gap in the robot. I mean, that would just be over the top. But this is the one I think you were mentioning.
Yeah, that's it.
That's the one right there.
And if you listen to what William Shatner says, he says, "What is it? It's just red lights that move back and forth."
Oh, that clip is pretty funny too. Yeah, because he says not only that, but then they get over to the other panel. He says, "What are these lights? They just seem to be blinking in random patterns." And he said, "Well, get on synchronizing them so they blink together." It's like
there's even a cartoon, science fiction cartoon with a drawing of that device in the background.
Yeah, it's pretty good. So
that's where you're going. The other thing with steampunk is you need a lot of rivets.
You need a lot of rivets. That's right. So there's and on that point you see there's rivets and like this is a 3D printed piece. You can see it's just a 3D printed plastic piece, but I did copper leafing on it.
And
so what I'm thinking is to help get that aesthetic that I like, I can 3D print whatever ridiculous shape that I want. And then you can get the leafing in gold and copper and brass and nickel and all these different kinds of metals. So
how did you make your rivets?
It's just 3D printed.
The rivets are part of the printing?
Yeah, just little hemisphere.
This was a single piece. This was a mock-up of it was meant to be a mock-up of a thing that would go in a 12-volt cigarette lighter to get power. So I was just mocking it up, but it also has a kind of a, plumbing kind of a look to it. So I figured
plumbing kind of.
And that's my and that has nice complex surfaces to see how the gold leafing would work. So as a process, it was really easy. Just sanded it down a little bit, and my wife's uncle sent me a little kit with the stuff that it takes, and anyhow, so
how does the leafing adhere?
What you do is you take whatever the part is, and there's it looks like Elmer's glue, but it's meant for leafing application, and you brush that on and let it get a little tacky dry on the surface, and then what you do is you get a nice wide flat like artist brush, and it turns out that you rub it on, it gets just enough static electricity that you hold it over the leaf, and it picks up a section of the leaf, and then you get it close to that thing, and then it just sucks it down, and then you tamp it down with some other brushes, and very quickly, I mean, this only took like 20 minutes, if that, to get it to this state, and then you can let it oxidize, or you can finish it further, but so anyhow, I'm working on aesthetics, right? So there's the just static aesthetics, but then there's these like Nixie tubes that'll have their own kind of unique look to them, and there's different kinds, not just the numbers, right? Because So you don't have to think about what to do with numbers. They have these little Decatron spinner things. And then another thing is this was with the winnings from Robo Columbus. Thank you, Club. So I got a handful of different sample material for EL, big sheet of flat blue, tape strip of green, a tape strip of red. And the thinking that I have is that these, they have such a saturated color, and they have a certain glow about them. And you can imagine if you have a kind of a texture like a grid, like if you 3D print a plate or you have some apertures, you can put this stuff behind there and have a really interesting look come out. Another thing, and I went and got one of these, is these translucent displays. So here they took one of these displays, and it's got a decent resolution to it, and you can project different images on it. So I got one of those I want to play around with. Actually, I saw a kit where somebody took 9 of these things, like 8 or 9 of these things, and stacked them side by each. So he has like a 3-dimensional display because you can see through them all. So it's a interesting idea. And then I also, long ago, I got one of these. So e-paper, they don't change very fast, but they have such a high contrast. So all of these things have a certain look about them. And then the other thing that I caught, aside from the spark gap, is, or Jacob's ladder, is, if it's going to be steampunk, there should be smoke, right? We should have a robot that can produce smoke without and still keep working, right? It should be able to produce smoke, and it should have a smokestack. So here's a guy that's figured out how to take the module from an e-cig and make it as a fog or smoke generator. So he did this on a model train, and that's now how he has a smokestack on his train platform. So I figured that could very well be coming to a robot at DPRG. I wouldn't say anytime soon, but that's kind of the idea, at least. Totally non-functional, right? But looks good, hopefully.
And it comes
And then so working backwards. So this was the Robo Columbus thing, right? Built on the base from Dave Anderson's son. And there's that OpenHV M7 cam, but it's all like one of our. It's just like exposed everything, right? It's not even cyberpunk. It's vintage duct tape and wire, right? And it was called duct tape and baling wire, so it's true to form. But I figured next time, I don't know if I could do it by next year's robot, but the one I want to do next is to combine this and steampunk or cyberpunk or something like that. So I actually have one of these kits now. It's still in the box because I'm still in buying mode, but it's a rock crawler, and I like this one for one because of its kind of 40s era look, I guess. But for another, it's because it has this big space in the back. So the idea is to get rid of the tire and maybe even this. I think it's mostly for looks roll cage. And then I would have a kind of you could imagine a stack that's decorated in steampunk fashion or alien artifact fashion. And then it would have maybe the oak delight on it. Maybe it would have some other sensors, but this would be my target for the next outdoor thing that I work on is to have something with this.
Carl, does that have rear wheel steering? I couldn't quite tell.
It does not have rear wheel steering, but it does have, I got the adapter so that it actually has a 2-speed gear mechanism. So you can throw a servo and it'll go from high torque to high speed. Really high torque to really high speed. And it does have, just look at the angle of the wheels on that thing. It can, I can't imagine trying to do this with sensors, but as a human, I think it'd be fun to play with. So, however I do it, I want to do it so that it's easy to move it from self-driving to automatic club driving.
Have you ever heard of a Unimog?
Yeah, well, that's what it's modeled after.
Oh, okay, good. So you know.
It is.
Yeah.
That's exactly what it's modeled over. So it's 4-wheel drive. It seems to be really well made, and
How much was it? I guess I could look it up.
well, this one's not. I got one of the last ones available for about $300 of the kit, but I think that's basically the mechanics. I think I still need to add all the running hardware, the motor and the radio and servos, battery. So it's going to get pricey, but I can see that I am hoping this will be something I can play with for a while. And it's a popular enough chassis that there's all kinds of third-party body parts for it. Like somebody has you can buy a kit, or somebody will let you replace these with working turn signals.
Carl, is there a picture of it without the body on the chassis?
There are, but it's the where is it? It's the SCX10, SCX10-2. That's another thing, is that this chassis is it's used in a lot of the Axial models. So another reason I like this is because I suspect that it'll have a long support life cycle. It's recently been replaced by the SCX10-3, but this was in play for so many years that I think it should be easy to buy parts for a long time. And even when I went and get, like I said, I got the 2-speed gearbox for it, and I'm tempted to go get. There's a metal set of gears. You can replace the main drive gear is plastic, and you can put a metal gear in there somebody else made. So
Yeah, after World War II, that was the ultimate, changeable vehicle. You could get plows and potato harvesters, and put just about anything on it. It's 4-wheel drive.
yeah, I guess it's probably like the Humvee of that era.
Yeah.
And a Humvee, I think, might have a wider kind of wheelbase, but I didn't see any Humvees that I like.
Yeah.
And I just like the look of this one, and I think the combination of aesthetic-wise of this 40s era style plus like steampunk alien artifact kind of thing, I think that would be a nice combination. So,
yep.
So that's the outdoor concept that I have, and then the other thing that's I'm toying with is you remember the hover sim that I have with Mecanum wheels, and as we learned, since this one has, even though it's a metal base, it still has these metal brackets, and as it got dropped and it destroyed a metal bracket, it hasn't been quite the same ever since. So what I'm thinking to do is, for the next indoor version of this, is to make one that has better suspension. So not that it can tolerate drops, but that it's not so sensitive to pressure and alignment, so that I can deal with uneven floors better and the like. So I'm thinking to this was the development version of it. So I'm thinking for the next version, it'll have suspension. Maybe it'll have that open MV cam facing down, so we could do line following and optical flow. But then, almost more importantly, since it's a Mecanum wheel robot and I'm after aesthetics, and I've got all these funky lighting ideas, I'm very seriously thinking that it needs to have a body that's a flying saucer. So, and I would make it a little bit thicker so that you'd have to get down low to actually see the wheels. But I'd give it some tail fins, and it could have lights for whatever. And so that's what I'm aiming for on the appearance of the next indoor one. So either steampunk or 50s sci-fi.
Hey, Carl.
Yes, sir.
There's a flying saucer robot that's part of that was used at the SparkFun AVC, and you might get some inspiration from it. And I know John's got the picture, and I know I've got the picture. So maybe next RBNO we can share that to you.
All right.
It was in the competition, big.
Yeah. Yeah, no, cool. I'm definitely in inspiration mode at the moment because there's
The other thing that there's a technique that should be available to us as Dallas MakerSpace members is they have a really nice vacuum former. I haven't used it in a long time, but it's really nice. That's nicer than anything I could cobble up. And
Probably a 3x4 sheet size, right?
Well, you can go up to that, but you don't have to. You can. It's got little sliding things to make for the size that you want. But that's another thought. So if you might want to make some robot bodies that move these guys out of the looking like they're kind of half finished all the time. That might be something we could do too. Is actually create some shells, especially thin shells that they use on the RC stuff is really thin.
Yeah. Oh yeah. Nice and lightweight. I had been thinking to 3D print, but
yeah, but he has a point. You could actually build a shell while you 3D print and then vacuum form around the mold, and you could get and it's pretty big. I want to say 24 by 24.
If you wanted to go that, if you wanted to go that big, but you don't have to. And but anyway, it's kind of cool, and that's like I say, you can get that thin sheet stuff, or you can go, if you really wanted something rigid, you can use thick ABS too, and it will do it too. So, but even as I have a little vacuum former that I got from my dentist daughter, but it's only literally about this big because it was made to make teeth molds and stuff. So, but I thought that it's enough to prove concept of what materials you can use.
Yeah. Well, that's the thing. So I'm past the proof of concept on getting basic mechatronics to work and software to do more or less what I want. Now I want to incorporate some appearance, I think, but
some style,
maybe. But that involves making a decision and allocating the time, and I'm kind of at a loss for both of those at the moment. I don't know how much I'll be able to do for a few more months.
That outdoor rover that you've got, this RC rover, I could see where like you say, you could take off those roll bars and that extra wheel, and you could make a box there that could be effectively nice looking.
Yeah.
That could hold all your electronics.
Hey, there you go.
What's that?
Ray's always got the big stuff.
Carl, this is the cover to one of the wheelchairs that I got, and you wouldn't think, it's got like little red reflectors on the back here for driving down the road. It covers up all the nasty looking wires and batteries and everything. So and this is the post for the seat to come up through here. So it makes it look so much better when this thing is sitting on it. It looks pretty cool. So.
It's funny. It doesn't take much, right?
So aesthetics, it's everything. So.
Cool. Hey, speaking of Carl's flying saucer, have you guys seen the little drone toys? In fact, I can present and show you that. Just sort of a segue from Carl's flying saucer. Okay, here we go. Let's see if I can figure this out. 1 sec. Are you seeing my thing here?
Not quite yet.
Okay. Let's see. Is it presenting?
Not yet.
Okay, wait a minute. I asked to present. Let's see. Let me switch back. Let's see.
Carl, are you talking about all these under $100 drones that have appeared here in the last year?
You mean Ron?
Is that what I said?
You say Carl.
Carl, Ron.
Ron.
Wait a minute. Let's see. Are you seeing? Wait a minute. Okay. Oh, hang on. Let's see what. I have to select the window. Hang on. Let's try screen 2. Okay. Well, first I'll show you this. Okay.
There we go.
Okay, we got a robot arm. Now let's see if I can get the hover star over there. One sec. Okay, we seeing that? Little flying saucer.
Yep.
Okay. Unfortunately, I have one of these that my brother gave me. It's a $20 or $25 little drone, but pretty cute. It's got 4 sensors around the perimeter and one at the top, one at the bottom. Let's see if they'll demo it here. Let's see. So it's about, I don't know, 3 or 4 inches in diameter. And it is a quadcopter, but the cool thing is you pitch it in the air and it starts to fly, and it has obstacle detection. And let's see, once they launch it, there it is, we're seeing it. You charge it up, whatever, all self-contained, it can't hurt you. And let's see if we can skip ahead a bit. Here we go, here it is flying around the room. Let's see, so you just chuck it in the air and then it recognizes, or I guess you let it go and it starts to fall and it recognizes it, switches on. And so it's got obstacle detection with, I assume, IR sensors, close range, but pretty slick. You put your hand under it, it'll raise up.
Oh, I want one. Carl,
yeah.
Put in the link.
Oh, okay. Let's see. Yeah, that's so it's Hoverstar, I think, or Hoverstar 360. You can get them. I saw them on Amazon. But I was thinking too, the other thing is you could probably hack it if you wanted to fake the inputs to the sensors. Now you'd have to be fairly small scale. I don't know how many grams you could carry, but you might be able to carry a single chip transceiver or something like that. But fun to play with, and we do flips and stuff like that. And it's got a number of different pagers, but lots of fun. And it's an enclosed drone that you don't have to worry about it taking a chunk out of you.
Plus, if you could dangle some legs underneath, you could get a big job at MIT.
Yeah, there you go. Oh, and I'll show you. Let's see. Then the other kind of fun thing, although I'm curious about it, is let's see. You're seeing the robot arm, I guess. There we go. So this, my brother's got this toy, and I'd like to have one. But the frustrating thing about it is it's about the size of your arm. It's really slick. And the last day I was visiting him, I was playing with a thing called RoboDK that lets you do offline programming. I don't know if you're hearing my voice. I'll mute that. Let's see. Anyway, so I didn't have really much time to play with it. So the only thing I could really do with moving it around was to just manually jog it because I ran out of time. He was having difficulty interfacing it. But the sad thing is it's cute, but it's 20 grand. And it's like there ought to be something. There ought to be a way to do this for a little bit less money. This has 6 degrees of freedom, and it is slick. But there ought to be something equivalent. And I know Will's playing with something. Let's see if I can bring that up. Let's see. I'll look for that. And it's a $1,000 robot, but it's it's a fairly simple bot, but it's kind of neat. Let's see if I can find that. Okay, I'm not seeing it. Let's see if it's in my history here. One sec. But the RoboDK is interesting, and there are free versions. But the problem is, if you want to do, you can do offline programming, but to do online where you're real time, it's $3,500. So it's an expensive piece of software. But here's a $1,000 arm, and I thought this was pretty cute. And Will is investigating using this in a pick and place type of operation, picking and placing little parts from a carrier into a work area that is operated on by a machine, and then take it back out to a pallet or whatever you want to call it, tray. So anyway, I thought that was kind of interesting at about $1,000. And but anyway, it'd be nice to have something more like that. Collaborative arm for less than 20 grand. Oh, the cool thing about that collaborative arm is it can move really fast, but it does also set up where it doesn't take your head off, which is kind of neat. So you can sort of work with it. But anyway, that's my story. So I don't really have anything. Just those are a couple of things that inspired my interest, and I will quit. Let's see if I can get rid of this. There we go.
Ron, the gentleman that gave the talk last month, no, was that here or was that out in California? At any rate, about his company, and he had a walking robot, but he'd sold a whole lot of these little motors he'd made for arms.
Okay.
Basically what it is it's a coreless motor, and in the center of it he put a what are those high-speed gear reductions that are called with
Planetary gear?
Planetary, thank you. He put a planetary gear in the middle, and
Okay.
showed us all this CNC machining he'd done, which was glorious. But as I say, the tabletop there probably had $10,000 worth of CNC parts on it. So I understand why those arms are so expensive. It's that little high-power compact motor, and you have to have 6 of them.
Mm-hmm. Yeah, and in this case, really, to make it efficient, they scaled. They have different size motors for, well, I guess a couple of the joints, pairs of joints, I think, are roughly the same size. But if you look at that arm, it's got at least 2 or 3 different size motors. Wow, adds to the expense. Anyway, kind of neat stuff, but that's just sort of fun stuff. And the other thing, Carl, is I was just thinking, you were talking about all your steampunk stuff, and of course another one would be analog gauges would be fun. And I guess the question there is, what's the smallest servo or the smallest drive if you wanted to have analog dials, to drive dials would be an interesting thing.
Why don't you just go down to Tanner's and buy some old analog dial?
Yeah, that's
actually on that, Ron, the best thing to get, and you can get this either on eBay or Amazon, are the little servo stepper motors that are used in dashboards for.
Yes, okay.
And they're really, I mean, the actual one, I used to have 2 of them floating around here.
Yeah.
And you can 3D print the needle to any style you want, and they're just really cool, and they're not very expensive.
Like that, didn't they?
Huh?
Adafruit, I thought, used to sell something like
Well, if you look around, you can find some ridiculously tiny servos. I mean, I found a linear actuator servo literally that has that kind of footprint.
Yep.
I mean, it's that, and there's a rotary one I had that size too.
Oh yeah, like do they use almost like pager motors or
No,
wait a minute, or they are steppers? Or
I have no idea.
The ones I'm looking at are steppers.
Okay.
In fact,
I'm talking about actual servos. I mean, servos that are standard PWM based, except they run on 3 volts and they weigh like a tiny fraction of an ounce.
Ah, okay.
So they have no torque, but I think they're the kind of things you'd use on like little RC planes that might weigh half of an ounce.
Right.
Oh, cool. We got all kinds of links. I put the links in of the things I shared, and then I pasted in, Ron, a link to the Hover Star 360.
Oh yeah, okay, yeah, and it's Hover Star. I think you said Start. I'm not sure what you put.
Yeah, I meant to say Star, but
yeah, okay.
I can't edit. And then
there's a number of different lookalikes, but I can attest that the Hover Star 360 is the one that I've played with, and it's cute. It works well, and it lasts about, I don't know how many minutes, 5 minutes on a charge. Little battery compartment. I don't know how big the battery is, but pretty cute.
Very nice.
Says here you can buy them for $14 at Walmart.
Oh, a Hover Star 360?
Yeah.
Oh, hey, I'm going. Normally, I just let Amazon bring it to me for $14. I'll find an excuse to go to Walmart.
It says $14.88.
Okay.
Yeah, is that through one of Walmart's resellers or retailers?
You were talking about little stepper motors?
Oh, there you go.
Yeah. Yeah, it seems like you can buy anything just about from Walmart. You look at who actually sells it and ships it.
So I guess really with something like that stepper motor, if Carl wanted to do a dial, you could do the old thing where you just run the motor up against, with your needle up against the stop. You know, if you've got we'll say 70 steps per whatever your gauge reading, crank it all the way against 0 for 70 steps, and then you'll know where you are, sort of thing.
And even have a calibrated dial to that.
Okay, here's a guy that will sell you a package of analog gauges, antique analog gauges for only $519.
Yeah, that's why I say make your own.
Is it Nexium that you can do like widgets and that kind of thing, where you can make something that actually looks like an old analog meter on an LCD display? I think they have something like that. I want to say it's Nexium or Nexus. I don't know.
Yeah, I wonder if there's any other options on the needle gauge driving thing, like, I don't know, what do you call it, the muscle wire, or, I mean, could you use a pager motor with where you're PWMing, you know, the pager motor with, let's say, a spring return or something, you know what I'm saying, like variable torque. I'm just throwing out ideas. The little stepper sounds good enough.
Somebody in a recent meeting, I thought, mentioned something about having a few old Microna test meters that they got specifically just to have the analog display. Was that anybody here?
If you look at I put a link in for those dashboard stepper motors.
Okay.
There's a gazillion of them all over the place. I just picked one to show you the picture.
You know, and I guess the cool thing there, sorry to interrupt.
They're about this big.
You know, the cool thing about the motor is you do get that true dial feel, whereas if you have a, whatever you call it, galvanometric meter, whatever you call that style, that's the magnet, the electrode in the coil, you know, that's usually got a pivot point that's obscured by a shroud or something like that. Whereas if you had your motor driven dials, then you've got, you know, a peg in the center of the gauge, so it's more like a gauge, an analog gauge.
Oh, these are meant to look like gauges,
right?
And the only problem, the only reason why you know they're a stepper motor is because when you turn it on, you have to go to 0. So otherwise, what they do is they go to 0 and then they go to the value.
Right.
And then once they're at that value, you know, they'll shift just like a normal meter. But
right.
When they're first turned on, they always have to go to 0 and then come back.
Well, of course, I guess if you shut down, it'd be good to 0 your gauges, you know, power down sequence, all the gauges go to 0.
Yeah. But it's really cool. I mean, that was my intent, was to use them I was going to use them for like a clock. Okay, just have 3 instead of, because I've built several analog meter clocks, and I have one around here, but I don't know. But this was an attempt to do it, and I was playing with it. The neat thing about it is you can make a really old-fashioned needle point, you know, one that looks like the old. If you look at a really old meter, it'll have what looks like an ace of spades on the end of it. And you can create those sort of type of things and have a lot of fun with it.
Well, and I think what Carl was looking for was something more like a steam gauge, right?
Oh, well, these would look like that. You can make them look like that.
You would have that little club or spade on the end of the needle.
Yeah.
That's right. So many options.
Something to distract you from actually doing something really useful, or
So I'll actually on the concept of clocks and gauges, I'll show you something here. This was something. What? The format's corrupted.
In my truck. I have to give it a hard twack to get them to read. You know, they get stuck at 0.
Yeah, that's it.
So these are These are clocks from a couple different Packards. Apparently, this bottom one was from a 1953 Packard, and the top one was from a 1939 Packard. And I'm not quite sure what my dad had in mind to do with them, but he was describing these, and this was the 39 Packard with the dashboard surrounding piece, and this actually.
Wow.
It must weigh like 4 or 5 pounds, but this is a radiator cap.
Yeah. Oh yeah. You don't want to meet.
Radiator cap from a Packard of some vintage. But the idea was he was explaining that these clocks, there's an interesting story behind them in that he described them as pulse wound electrical clocks. So think about it. In 1939, he said this may have actually been the first instance of having an electric clock in an automobile, was that Packard. And he said that the way that it works is that it's actually behind the hands as a spring wound clock, but the spring has these contacts. So what happens is when the spring is fully wound, the contact disengages. When the spring goes down and the clock is unwound far enough, then it starts to draw power from the motor and it winds the clock spring, and then it hits the end and it disconnects the motor that drives the clock spring. So he said that, and not only was that the case in the 39, but even in the 53. But he said in the 39 version, it was so that people were really concerned, right? Think about it, in 1939, this is the age when you knew what happened under the hood of your car because you had to fix it all the time to keep it going. And batteries were in no way then what they are now. So he said that as much as an innovation as this was to have an electric clock in the dashboard of your car, he said that people were so concerned that it was going to drain the battery down, they wouldn't be able to start their car, that the standard thing to do was if you got one of these Packards, you would snip the clock wire so it wouldn't work. So anyhow, yeah, I don't know about this. It's a little bit too large to think about putting in a robot, and it probably has more value than I wanted to do that anyhow, but it's interesting to me anyhow. And yeah, there's a neat aesthetic to that vintage stuff.
Well, you know, and 60 years later, in my wife's vintage 96 Mustang, I had to add a battery disconnect for sort of the same reason. Somewhere in the car, and you know, at that year, there was probably at least a dozen microcontrollers, maybe not quite in 96, but I had to add a disconnect, something sucking the battery, and God knows what it is. I mean, to diagnose that would be rather difficult.
Well, I had a MGTD, and it had Lucas tachometer and speedometer. And
well, there's your problem right there.
Yeah, and the way they work was that they actually had a clock mechanism in it, and the shaft would turn and make the clock, drive the clock. And what it would do was the clock would measure a certain period and would count how many revolutions there were in that period and set the dial based on that. And what was fun was with the tachometer, you would rev the engine and cut the engine. The needle would go like this. And the tachometer quit, and I was able to disassemble it and fix it and put it all back together. But that's why I knew what the mechanism was. It was a weird piece of equipment.
Dave, is that one of those little tiny Triumphs that you can hang your hand out the window and drag your knuckles along the ground?
Yeah, that was the kind. And in fact, the way I would start it when the battery was low is I would the door opens the opposite way. That is, instead of it opening backwards, it would open frontward.
Suicide door.
Push it down the driveway backwards and jump in it, slam it in gear, and that would start it.
Throw it in reverse, huh?
It's a little tougher with a 55 International Harvester school bus.
Yeah.
We had a starter fail on that, and this was being used for like marine biology, taking kids down to Key West. But we had kids with us, and I mean, I was a kid myself. So for that whole season, we didn't have a functional starter. So we'd have like about 10 kids jump out of the bus, and we'd all push the bus to get it going, you know, and then pop the clutch. So there was a solution. It required multiple people.
Here's one of
his,
Here's one of those servo motors. I mean, yeah, right here. This is meant for a dashboard.
Oh yeah, turn it so we can see the. Wow, it seems rather large. Wait a minute.
Well, this one might be for a large dashboard. I don't know.
Large.
Now the needle is 3D printed by me, so it's not.
Oh, here you go. Dave's got. Yeah,
Yeah, Dave's got a little one too.
one with his tweezers.
About maybe between a quarter and a third of an inch on the side.
Yeah. And this one is big and flat.
Yeah.
But they do work. I did play around with them enough to make the needle do all its cool stuff.
In my 1965 Chevy, it has a mechanical speedometer, and there is it's like a worm and worm gear connection to the shaft that comes out the side of the transmission. Anyway, there was this little teeny clip that held this one gear, which one? The worm, I guess it was the worm gear, onto the, output where you'd attach the speedometer cable. Anyway, it came off and the gear pushed back and on the shaft, because that's what held it in the shaft. And I couldn't get my car inspected until I found one of those little teeny clips to put in that thing. So anything mechanical can be a nightmare. Actually had to take the drive shaft out, take off the back of the transmission, put in the new clip, put in a different gear because my speedometer wasn't reading right, and stick it all back together. So, and all that just to get it inspected. So
You may remember back in the day that almost any control cable that went through a outer shroud was generically referred to as a speedometer cable for all kinds of things.
Yep.
Oh, our host vanished. Does that mean the meeting is over?
We should all leave quick before he comes back. Oh,
Not this one. Does that only have to do?
Boy, we got nervous, Carl. It's like, oh my God, Carl's gone. No.
No need to hang around. Pay no attention. Okay. No, I was trying to dig something out, and it obviously I couldn't dig it out fast enough. But no. But well, does anyone else have some ideas, inspirational YouTube browsing, or anything they want to share?
Yeah. Take me a
Ray
second.
does.
Oh,
Yeah.
Ray's got something.
And I think you guys have seen some of these things. This is, I guess I should present.
Ray is now going to randomly search YouTube. No, I'm just kidding.
There you go. No. I think you guys had seen these. These were older videos that I did. I've been working on these platforms for a long time. Okay, is it going to play? Okay, here we go. This is using 2 wheelchair motors. It's just in RC mode, radio controlled mode. But on all the platforms now, I've gotten rid of whatever processor was on them, either Megas or, Uno equivalents or something like that. I've gone to the ESP32. So now anything radio controlled is LoRa. Um, and they all the platforms had RoboClaw controllers on them. Either different sizes, like either the 2x60 or the 2x30, and it actually worked pretty good. I also had a first-person view camera on it, and I could show, I could see where the thing was going, and basically sit inside or within range of that camera, so I could control it, and see it where it was going. The other one, got out of the photos. Didn't mean to do that. Let's see, photos. I think this one's actually on top. And this was the other one was basically parts off of a riding mower. It's got a 42-inch deck and a 10-horse gas engine. And I also wanted to try to do the same thing with a push mower. And I had a couple different versions of this. This is my RC LoRa controlled box now. I don't use I was using a plain remote control, but now this is what I use. And
So for outdoor contests, are you allowed to mow while you're executing the contest?
no one said I couldn't.
That
So,
seems only fair.
wherever I'm at, I don't know if the person would appreciate that.
I like your container. It looks like it could also hold your lunch.
Yeah, it's lunchbox, spare parts, anything. Yeah, and that's what's kind of nice about those. You can hook up a battery to it. It can actually charge the battery from the USB. So.
Ray, you have plans to do some things with this moving forward now?
Well, what I wanted to do, these were all differential drive, and I've got a riding mower that was, Ackerman steering, but the Ackerman steering, it's difficult to follow GPS coordinates with that because you can't, like pivot on a wheel or, turn in place kind of thing. And it's just more difficult to do. I actually wanted to make a 4-wheel drive version of it. Oh yeah, and this was my fail. I found out that my tires were actually spinning on those gray plastic wheels, and the thing was barely moving. And there's also a flap underneath that was the corners of it were folded, and it's supposed to just push backwards and prevent so much of the grass clippings from coming at you. And it was actually sticking on our coarse grass here. That's very little grass and probably mostly weeds. Anyway, yeah, I didn't realize that until I got up closer to it. I could actually see the hub, and they were slipping on the ground as well. So, but I think I came over and showed where it was just spinning in the wheel. Anyway, so these are the 2 differential drive robots that I have. Yeah, see, there it is there. See, the tire's not moving, but the hub is. Anyway, so those are the 2 that I have. The third one is the riding mower with Ackerman steering. I have a linear actuator to actually move the front wheels back and forth, and I bought a hydrostatic transaxle for the mower, and that just uses a servo to pull a lever up or down to go, in the forward direction or reverse direction. The more you pull it, the faster it goes in whatever direction you're pulling it in. But I wanted to make a 4-wheel drive version of it because I just think it would work better. I could do kind of the maneuvers that you would want to do for, for GPS positioning a lot easier. And I think I had showed you. Now I'm going to do the search on YouTube. So this one guy had a very neat approach, and this is what I'd like to do. And he had it so you could attach different things to it. I thought it was pretty cool. And now I'm not going to find it. Oh, here it is. The wheels that I have on the riding mower are really too wide, and I think this guy, I'm not certain where he's from, but he made a separate platform. Can you see that?
Yeah.
Where you can attach different things to it. And he's just using bicycle motors here. I think they're 350 watt. And it looks like the thing will go through anything. And since that's what some areas of my property look like, that's what I need.
Very happy soundtrack to that video.
Yep.
Hey Ray, does he show a build video on this?
It might come here in a second.
But is it remote? Oh, it is remote controlled, not automatic.
He does in another one.
I like the comment he has down there. For those asking for plans, it's not rocket science. Did you see that? Right?
It's not rocket science.
I'd
No.
slash down to the comments. Keep sliding down a little bit.
I'm sorry, Doug, I couldn't hear you. What'd you say?
I said, if you slide down through the comments, he's got a comment. He says, those asking for plans, it's not rocket science.
Build your own, I guess. Huh?
Yeah. But I was curious about how he handled the it's very neat idea. How he handled the chain drives.
Oh, it looks like he just has, he's got the same size sprocket on each wheel.
Yeah.
And he's got like an idler, I think, underneath between the two wheels.
Okay.
And that goes to these two. I found out that was the only English text I think I could read, was that it was a 350 watt bicycle motor on either side here.
Ray,
24 volt.
At the very beginning of the video, it showed the frame, the outer frame attaching the inner. Are there any more views of just the outer frame by itself?
There's another video here that I had played before. I don't know if it's in this one or not. This one may show more of the. Yeah, this is an older version of it, so it's not the same. Yeah, can't understand the word he's saying, but I'd like to by just the frame itself too. So I don't know if there's a mix, but there's several videos there. Anyway, that's the kind of thing that I wanted to do. I've got much smaller wheels than this that I actually welded. I found basically a sprocket that would fit inside the hub, and I drilled holes in the hub and welded the sprocket to the hub. So I pretty much have the wheels down, and I just make like a rectangular frame and have two sets of chains coming from each wheel to a wheelchair motor that was placed about in the center, and as opposed to one chain like this. But yeah, I thought that was a neat concept, and that's what I'd like to do. Okay, is it still sharing? It is still sharing.
You stop sharing. Oh, good.
Okay, there we go. Anyway, so that's a lot of the stuff that I've been playing around with, and I think changing processors and is really, I really like the SV32s. That the little board that Kevin showed is the later version of the ones that I have, but it's got LoRa transceiver. It has Wi-Fi. It has Bluetooth. I2C, SPI, serial interfaces on it. It's got a connector for the battery in the back. If you plug in USB, it'll charge the battery for you.
Ray, can you put in a link in the chat?
I did earlier.
Okay. Thank you.
I said I think this is the one I use, but yeah, the one that Kevin showed was the later revision of it. So that's kind of where I'm at. I'd like to move on to the four-wheel drive version. There's some weird things you can do with differentials if you have independent brakes on each axis of a differential, and you turn on one brake and stop one wheel from rotating, the other wheel will rotate. So you can actually pivot on a wheel, the wheel that you're braking. And that's a little more complex setup. It'd be like a skid steer, but the amount of time that you applied the braking would actually be your steering. And I think that might be kind of difficult to do because you're overcoming, obstacles, slopes. So the amount of braking is going to be different depending on, what the terrain looks like. So I don't know if that's going to be as productive, but definitely wanted to play around with a four-wheel drive platform. And it'd be nice to make it similar to what he's done. I only have lawnmower decks to put on the thing. I don't have anything else. So he had, I think, 3 different things you could stick on it. Of course, I don't know. I think his sweeper was just a lawnmower with a bag on the back. That was his sweeper. So, so I don't know what the third option was. But anyway,
Cool.
playing with the big stuff.
So you're playing with the big stuff, and while you're doing that, I found approximately what I had discovered before. But so at the other end of this of the size spectrum, there are these tiny little servos. Look at this thing; it weighs like 6 grams. And Pat, that's for you. It's a Canadian penny, so it must be a Canadian servo, I guess. But and then there's also this one. This one weighs 2 grams.
Yeah, teeny
and it's a linear, so I guess when you move it, it slides back and forth.
Yeah.
Linear throw, but
yeah,
I've got a couple of those somewhere. Pretty cool.
I can't imagine that. I mean, they're not going to have much torque or force, but in terms of moving things that might have a physical change on appearance, so aesthetics, I think. Anyhow, they intrigue me. I don't know what to do with them just yet, but.
Hey, Carl,
maybe more torque than you think. Because
yeah,
depending on the pitch, it means a lead screw.
Yeah.
Slide down.
Well, 100 grams.
Yeah,
That's pretty good.
All right.
3.5 ounces. Yeah.
Yeah. So, yeah, and I don't know what the other one was either. So it's 12-inch ounces. So I guess that's pretty good too, isn't it? It's even ball bearing. So I don't know. I don't know what to do with them, but in terms of fun parts, you know.
Yep. Yeah, I bought a linear actuator from Tanner's. It was like $10. Didn't really know how much force it could produce, and tried it on the riding lawnmower to, steer the wheels, and just sitting on a smooth concrete floor, it didn't have enough force to turn them, so I had to get one that I knew what it was. It was actually 55 pounds of force to be able to turn the wheels when it was just sitting there. It's easier when you're moving forward, but I'm sure there would have been, if I assumed there'd be a situation where I wasn't sitting still and wanted to turn the wheels, that there would be one.
Carl, my first proportional radio control system I bought back in the 60s, which was made by Bonner up in Chicago, used those linear actuators with a harmonic drive. And the cool thing about the linear actuators is, with a rotary actuator, the amount of movement of the surface changes depending on where you are around the circle. And so you don't get as much throw as you go further as you do in the middle. And so with a linear actuator, that's not true. When you move a certain amount, the linear actuator moves a certain amount, the control surfaces move the same amount. So I was actually kind of disappointed when I saw those all disappear. And if you've ever set up a RC helicopter, there's a long, long process that you use to try to balance out such that the servos give you exactly the same amount of throw in both directions at exactly the same angles at both directions, which you can then linearize in the software. But it's real complicated to do. So I can see all sorts of uses for those little tiny linear actuators. It's really an advantage over a rotary actuator.
Yeah. Especially, I wonder what the transition time is. I didn't look that closely.
It looks like 0.1 second end to end.
Oh, wow. Oh, yeah.
0.1, wow.
And the
It'd be
throw,
there
it
before you
doesn't say
knew it.
what the throw is.
So they would serve like what David was talking about. They're sort of on the servo speed type, actually fast servo.
Probably a throw of less than 2 centimeters, though, right?
Or maybe put it inside of an animatronic head to blink the eyes or move.
Yeah, that's little window shutters or tiny things to move.
Yeah, that's the other thing on the linear actuator. I didn't want to wait forever to have the wheels move. So, and it seems like you just can't get one with I think I wanted under a second from one extreme to the other. And the ones that, that push or pull 55 pounds, they barely do that. It's like a little bit more than that. But it's kind of like driving a car. You're not going to jerk your steering wheel end to end going 60 miles an hour. You'll flip, So at, faster speeds, you don't have to turn it as much, which is nice. But at slower speeds, you do. So you may have to slow down more than you want to be able to get so the steering catches up.
Cool. All right. Well, let's see, guys. We've gone around. I hope it was good so far. Worthwhile way to spend a couple hours.
Does 7 Photons have something to share?
That's Jack, and Jack is studying. I suggested that he not pay attention and focus on studying, but I guess he's half listening anyhow.
I want to know why 7 photons? Why not 5 or
8 or
9?
We should ask him.
Is that the number required to cause an avalanche, or You know,
Maybe
I
it's a
think he's
reference
studying
to
those, so he,
7 of 9.
yeah.
Yeah.
Let's catch up with that and ask him. I don't think I've ever asked him that. And by the way, Jack is working on a presentation for us. It might be December, it might be after that, but I think he'll have a presentation for us. We've been talking about for a while. So, okay, guys. Well, if there's nothing else, I'd suggest we get on and enjoy the rest of the weekend and catch up next Tuesday night or whenever. So, good to see you all.
Okay, so until Tuesday, take care.
Until then.